Okay. Hello, everyone. We're back for another episode of This is Learning. We have Liran here today. He is a security expert, or so he tells us. Hopefully, we'll know if that's true or not by the end of it. So he's going to be here talking to us about Node.js security. Sounds like maybe a little bit of DevOps security. I took a peek at your Twitter profile, and you were talking about Docker container security and all that kind of stuff. So
True.
should be a pretty informative session today, because I feel like a lot of developers, and this is why it's such an important topic, don't know a ton about security. So yeah, hopefully we learn something. Before we get started, I just wanted to shout out to everybody that This is Learning has a couple of new communities, Twitter communities. There's a pinned tweet under our Twitter handle, which I'll share on the stream in a bit here. So go join those if you're interested. Otherwise, Liran, I'm going to pass it off to you. Over the course of the stream, I might pop up some questions. Feel free to answer them, or we can get to them at the end and have a couple of pre-planned ones. So I'll pass it over to you.
Cool. Awesome. Well, thanks, Jay, and hey, everyone. And yeah, this is going to be a bit about security and live hacking some apps. So feel free to run anything on the chat. And Jay, I hope that you're ready for like live hacking, because this is what we're going to do today, basically.
Totally.
Cool. So a little bit about me. A bunch of stuff, mostly doing web security activism on like the ecosystem. So anything like JavaScript, Node.js, OWASP, and a bunch of stuff. If you have any questions, anything, reach out. I'm also a developer advocate at Snyk, which is kind of like a web, not web, it's a developer first security tooling, but everything for me is like, translating automatically to like web stuff, web security and things like that. So I actually don't want to go through the slides. I actually want to go through like some live hacking stuff and like get some questions from you. Like, what do you all care about? Jay, also yourself, like, what do you care about? What do you want to learn? What are the topics that are interesting in terms of like the whole web security, JS, JavaScript security kind of topics? Would be cool to talk about, open source security as a concept in terms of, we're using a lot of NPM packages. They have some vulnerabilities in them, backend stuff, front-end stuff, so whatever you care about. Well, maybe that's my Slack. I'll get that muted in a sec. But as we go through that, so let me ask you, maybe, Jay. Let me like turn this over. Like, what questions do you like? What topics have you heard about in terms of just like security in the space of JavaScript, maybe?
Yeah. So I think something that would probably be very beneficial for everybody is just kind of like the basics. Like, what are the absolute basics that someone would need to know about building in Node.js? Like, can I just go read a tutorial and build a Node.js API and I don't need to worry about anything? I'm assuming the answer is no, but if it's no, what do I need to be worried about? Like, what kind of stuff should I be paying attention to or looking for?
True. So I guess in general, so many things, and APIs have their own like some specific threat attacks. But also just in general, writing code, right? Like whether that's a backend or a front end, there are many things that are very similar. For example, one of the very first thing that you should think of is definitely like user input and what do you do with it? Are you validating user input? Are you sanitizing it? If you're getting user input and like you're doing some, let's say like you need to like output it somewhere, for example, like front end, you need to like output user input as like a form field or something. Then you need to do it in a correct way, which means to encode it in the correct context. This is why, for example, if you are doing front end with React or Vue or Angular, and you've heard like they are secure and safe by default, what it essentially means is that they take any input you give them, and unless you like tell them anything different, by default they will output encoded correctly. That's why if you put like JavaScript alerts somewhere or like script tags and stuff, they don't actually render as like an actual DOM HTML element, but rather they just like, this is just a representation of the text.
Yep. Yeah, I'm an Angular dev, and one of the biggest hurdles that I had when I was first learning was inserting HTML using like the inner HTML attribute, because Angular will essentially not allow unsafe resources, right? So you need to like kind of juggle that and figure it out. So
Yeah. And there are some kind of escape hatches, even for React, right? To have like, the dangerously set inner HTML, which you may know, not to use at times. Sometimes you just have to use it, and then you need to figure out a way. But also dependencies may just use that API, and you are not aware of it.
Exactly. Yeah, which leads us really nicely into the next topic that I wanted to discover, which you actually already have a slide here for, is like supply chain attacks. Like, how do we implement like a secure development lifecycle? Recently we saw it with the UA parser JS npm package, where I think someone got access to the developer's account and published a new version that had a miner, like a cryptocurrency miner in it or something like that, I think.
Yeah. So yeah, open source as a supply chain is something that's on everyone's mind. It's did you hear about the vulnerable VS Code extensions or not yet?
No, I haven't heard about that one.
Okay, so this is it's something that we discovered at Snyk and like released that research. But essentially, I like that story because everyone think about like software supply chain in terms of like open source, like the dependencies that we have, which is definitely like this is the first thing you'll think of, and that's fine. Open source dependencies are everywhere, and it's an issue. But like as you said, like supply chain is all the way from like my dev environment, right? Like my dev machine, VS Code might get compromised, right? Like if I'm using an extension that was like I installed a malicious extension, or the fun story with that research is that we found that some extensions that have like 500,000 and 1 million or something like it. The total is like few millions of downloads from users. So like they're very popular in terms of like installed on the dev machines. And they're not malicious. They simply have like there's a vulnerability in there. One of them is like a markdown previewer that you could like view the markdown on the side pane, which I use a lot, for example. Like everyone does markdown.
Yeah.
Right. So apparently to do that, to like render that markdown, that like the HTML view of the markdown that you see, essentially it runs, it spins off like a local HTTP server. And the fact that it does it there's like a specific way of this exploitation to make it work. But I could essentially just send you a link, and just by you clicking that link, I could essentially just access any sensitive file on your system because there's like a path traversal vulnerability there. So imagine like someone puts that link in like a tweet, like Reddit, dev.to post, whatever. Like they just put it somewhere, they send it to you in like a DM or whatever. The moment you click on it, that's game over, right? Like it's a one click away from being hacked. That's just like vulnerable extensions. This is not even something malicious or something,
Totally. So, yeah. I just posted, I don't know if you saw this one, but the GDE community shared this recently, exploiting NPM packages with people that have expired email domains, custom email domains. That was a very interesting read. But yeah, it's in there. So we have a couple of questions. To start off, what are secure coding practices? So like of late, we're hearing a lot about secure coding practices, but like, what are those? What does it mean to be secure when coding?
Cool. So yeah, I like that because like it takes us from the slide stuff and talking to answering questions from real people. Great. So let me take you through that. So I basically have an app here, which is an intentionally vulnerable application. And when you talk about secure coding practices, one terminology that you should be aware of that's like more of like a security lingo is something that as developers, you already actually know of. It's, ASTs, like abstract syntax trees, where you go through like the call paths and like analyze all of those stuff. Basically what linter do, or ESLint does. So secure coding practices are essentially, from the security lingo, are called or are referred to as SAST, basically static application security testing, which means there's maybe a tool or something that helps me go through the code and tells me if I'm not using maybe secure coding practices, or essentially I have something that's also a technical terminology called source to sink. Like there's some input from a source somewhere, for example, HTTP parameters, like query parameters, if you're talking about the backend stuff, maybe, or user input goes into like a form or something, and then outputs into like an XSS DOM element or an SQL injection, like different things. So is that source to a sink is essentially holding in it a lot of vulnerabilities. Some of them are over here. So like I've basically, to demonstrate what I mean is I've got the Snyk VS Code thing installed. And if we go through like it kind of like analyze parts of my code base here, this is, let me see if I have this. Yeah, so I should have just open. Should have this app running. We played with yesterday, so you could see a bunch of stuff in here. So this to-do application is basically vanilla JavaScript and Node.js all the way. And so my tool here, my extension, installing it just found 21 vulnerabilities. Now, what are those vulnerabilities? They basically uncover those secure coding practices, right? For example, looks like there's unsanitized input from the HTTP. Oh, this is fixed for some reason. No, it's not. There we go. So this one tells me there's unsanitized input from the HTTP request body, and I can like go through the call flow here. It's like now I'll just turn this one off. No. This one off, and so we can see what's going on. Essentially, this function, this create function, this middleware on the Node.js backend, takes a request and a response. It does something with the request. You can see the curly braces, kind of like a linter error because it found some issue here. And you could see it called exec, which is a system command. So it executed a system command on like the shell or like the container running this Node.js backend API. And it does identify and it concatenates URL. URL is essentially coming from user input. It's not as obvious because it goes through several places there. Like it goes through item, which then gets its input through like a string matching here, and sorry about that, and then like it gets extracted. But essentially it's coming from user input. So for example, this is like the basic injection stuff. Like the example here is executing system commands, but it could just as well be like logging something that you shouldn't be logging, and it will be you haven't sanitized it, so there will be log injection, or SQL queries, and then it will be SQL injections, and no SQL queries like MongoDB, and then it will be no SQL injections. So all of those cases could really happen. And so the correct way of doing this stuff is, of course, using the correct APIs. For example, instead of using exec, what we could have done is essentially use some so child process really has exec file, which is the more secure API. So I could use identify, and then I kind of like hard code the command that I need to write to execute. So for example, if this was like something that clones, like a server that in Node.js that clones Git repositories because it needs to like do something with them. So I could just kind of like hard code the Git CLI, and then all of those other stuff that I want to give it as input that maybe I have to do it because like you can imagine that this is essentially a small example of what GitHub does behind the scene for like different things.
Yeah.
Right. So like it takes the user, but now the URL as an input can't be executed in any way, right? It's just the system understands that this is a path, an array, like a command argument to Git. So as a command.
Gotcha.
So
cool.
It is part of it.
Oh, that's awesome. I didn't know. But first off, that's an awesome extension. And that's an extension that your company built?
Yeah, that's definitely. That is, by the way, Snyk is free, so I haven't mentioned, but this is like you could install it, you could get running right away.
Great. That's awesome. Cool. Cool. So kind of tangentially to the JS ecosystem and, security concerns, what are your opinions on Deno's security model and that of its ecosystem, if you know much about Deno?
A bit. I haven't delved into that. I would be honest to say that I haven't spent a good amount there. So essentially, I think the promise for a good security model there is the sandboxing. So the fact that, for example, if you wanted to install some modules and they would be trying to execute code, so that is sandboxed. If you could go and say, for example, my ESLinter, when I run it, it only has access to file system. It doesn't have access to do network calls. So from that concept, for example, like we've had seen incidents, security incidents in the past on NPM, which if you install an NPM package and it was malicious, it would like read credentials from your disk, like environment configuration and your .npmrc token and stuff like that, and it would send them over to Pastebin or somewhere over the network to the attacker. So you could say linter doesn't need access, like ESLint as a package doesn't need access to do network calls. It just needs to do read and write, maybe IO operations on the disk. And so I think the idea there is we demo that's from the start is kind of like sandboxing and having this much fine-grained permission model of how or which resources are acceptable. So I don't know to which extent they have further developed that, but I do know that this is part of the promise. There are other issues there, for example, importing HTTPS modules, which made it into Node, I think experimental something 7.10, but I haven't looked at that either yet. But this could be essentially a problem in terms of if something you're getting it from HTTPS, how do you know it hasn't been typo squatted to something else? How do you know the maintainer is still the same one, and so on? There are a ton of a threat vectors that are kind of people could eye into, and so that's one issue.
Cool.
I will say that Node has, this is a while back, Bradley Mack, one of the core contributors, have actually created this capability called integrity policies, which was experimental to one of the earlier versions. I think now maybe it's already you need to flag it on the CLI through using command arguments to the Node runtime. But you are able to also have specific integrity policies for modules. So for example, what I mean by that is, imagine someone had access in some way to change the underlying code for the Node runtime, the modules installed. So they would you would think that you're installing I don't know, Jest, or Jest is not a good example, but Axios as an HTTP request as library. So what if someone would actually, as part of trojaning you or backdooring you in some way, an npm install, a malicious one, would actually replace the code in Node modules, Axios.js, whatever, with some malicious code in there? How do you know no one had tampered with that along the whole supply chain, the build, the CI, the install, everything? So that's what integrity policies have been built for. It essentially, you run it. It creates a trusted state of all the signatures of the current state that you trust, and then from then on, if you try to somehow alter code, even at runtime, which happens a lot because JavaScript and real-time evaluation, that protects you from it. So I would also look at Node in terms of the new and modern way of basically protecting yourself.
Cool. Good to know. Okay, moving on a little bit. Should we consider security alerts for dev dependencies as false positives? This is from Lars.
Hey, Lars. Should we consider security alerts? So, okay, that's always coming up. So it's tricky, right? My take is essentially you want to optimize for two things. One of them is reduce the noise, because developers deal with so many things. They're now responsible for their containers, writing tests, doing accessibility, whatever, everything, and everything else. So essentially you want to kind of reduce the noise. So I would say dev dependencies, if you kind of prioritize it to get back to them later at the sprint end, I don't know, whatever, I can understand that. The caveat with that is two things. One of them is potentially you could have a malicious package or a malicious version of a legitimate package, for example, event stream, as a dev dependency, right? That literally happened 3 years or so ago, right? Where millions of downloads, that was a malicious version there for 3 months. No one found out about it until later, etc. So complete chaos as a dev dependency thing that was not just dev dependency, it was a transitive dependency to things like Webpack and stuff like that. You'd never find it. But those are the 0 days, right? Those happen rarely. So when they do, it's kind of it's bad, but they do happen really, really rarely. What you do want to do is kind of ignore all of those regular expression denial of service or prototype pollutions in Jest and all of the dev dependencies that no one's going to hack you from having a denial of service attack into the ESLint running on your machine. It's an npm run test locally. So that is one angle of it. The other perspective of why you probably want to fix things, and that is something that I kind of realized just recently, is that you may have some tooling like bundlers that may be defined as dev dependencies, but they actually introduce dependencies into your code. So think about bundler, which actually transpile, for example, through CSS or something like that, and just works through the code. Now, the bundler itself or something like that will be a dev dependency. It doesn't need to be deployed anywhere. So you'd ignore it, but essentially it may be using post CSS or post whatever JS kind of utility that may have some sort of vulnerability in it that you won't find because you're ignoring dev dependencies. So at the end of the day, it comes down to you need to prioritize and introduce context to understand if something is important or not. So I don't consider them at all as false positives, but those two aspects are really important.
What about post-install scripts? How do those factor in here? Because some packages can essentially willy-nilly run post-install scripts currently, which can execute pretty much anything.
Okay, so so I wrote this tool back then called NPQ, which what it does is when you see you're trying to install something, like you're doing npm install amp html, whatever that is, and you see this is not the normal behavior of npm. It doesn't really, you don't see that output. That's because I'm basically aliasing this npq command with npm. So by just installing npq and aliasing, which is a very simple step, what I'm introducing myself here is I added to npq some kind of I call them marshals, and what they are essentially tests, like heuristics. So before I install amp html, I can check that it doesn't have post-install scripts or pre-install scripts or all of those scripts. So and if it does, it will tell me. It can check if there's no README. It can check if they have like 20 downloads, which I should be careful for because maybe it's like a typo squatted package and I accidentally wrote something else that I didn't intend. So yeah, npm install scripts are kind of a nightmare. I will give this a practical recommendation. Please upgrade to the latest npm CLI, like the npm 8.15 or something like that. They have recently released something that also fixes a sort of vulnerability with like npm CI locking files incorrectly. But npm 8 also has a fixed behavior to a way to like ignore scripts, which is if you also do npm install amp html, for example, if that was malicious, -- ignore scripts, that would ignore all of those scripts. Just that prior behaviors of npm were like ignoring everything. So if you have that in your .npm-rc and you try to do npm run test, it's broken. It doesn't work. npm 8 fixes that. And so adding now ignore scripts as part of your .npm-rc configuration for a project, that's like a real lifesaver. So all of those are like a couple of tips that you should probably look at.
Sweet. Okay, cool. Let's get back to you. What was the next thing that you wanted to talk about? Because we just had a lot of questions come through.
Okay, cool. Let's do a quick, I don't know, let's see if we have time for it, if it works. I'll show you what happens in terms of if I scan a project. Come on, let me find something. Goof project, the to-do application. This is the Docker image. No, not this one. So let me go here. I think I have it open in some of the tabs from earlier. Yeah, that works. So I basically just imported my GitHub repository into Snyk. So it has like static analysis Docker file because it has one, and then package.json. So I'll open package.json, which means I can look at all of my dependencies. So this is for the same to-do application that I showed you before. And I have like a bunch of issues, right? Like I can see a kind of like a summary of what do I need to do to fix them. For example, upgrading MS from this version to that version fixes just this, but ST fixes a bunch more, and so on and so on. I can look at my dependencies as a tree or as a list, depending on how I want to see it, and get like a nicer view of like where vulnerabilities are coming from. Maybe sometimes they are kind of like nested and hidden in some kind of like in the tree. All of those are great, but let me show you something. I'm using Dust, which is an npm package, which has a bunch of issues apparently here. Just a couple of them actually. A prototype solution, which appears to have a proof of concept. So this is probably why it's like getting a higher score and like prioritized. But also there's like a code injection, which definitely is something I should fix really fast. Now, Dust.js is a template engine. So let us see from like just Snyk telling us, hey, there's like these vulnerabilities. How does that actually impact the app? And I think it also connects nicely to like secure coding question, which we were asked before. So this is, let me kind of take you through what I want to show you here. Let's go back to the to-do application. I think I have a route here called about new. I do. Okay. So this route about new in this application is basically, let's see, about new Dust. So this is me using the Dust template engine, which is like a EJS or anything else. Essentially, this is a way to define a view, render it on the server side with some logic that dynamically gets interpolated, and then return an HTML to the web browser. So this is pretty simple stuff, basic stuff with template engines on Node.js, and very often used depending on like if you're building SPAs or something else. So I have this logic here, which has if condition. Let me make it bigger. Maybe it's going to be a bit easier for people.
Perfect. Yep.
Yeah. Okay. So I have this if condition of device equals desktop, right? And so depending on that, I show the font in like different sizes.
Mm-hmm.
This device is coming from here. So I can do if device is a mobile, it does something looks like it's big. If I do desktop, it's kind of like a smaller font.
Mm-hmm.
Amazing. This is, by the way, mobile first tested. This is as far as my CSS skills are going. So yeah, don't ask me to do content.
Same. Yeah.
Oh my God, thank you for saying this, Jake. Now I don't feel so left out.
You're not alone. You're not alone.
Oh my God, thank you. Hey, we have a Twitter list for people who can't align center divs in the middle. I'll add you to that. It sounds like you're
perfect.
there.
I belong there.
Cool. So what can go wrong, right? We have query parameter updating basically the view here, and that's it. Like look at this. This is the view. There's no other logic. This is just me using this, right? So condition device equals desktop. That's it. Nothing else. Mm-hmm. Now the thing is, as we talked about secure coding conventions, the issue is not just because you're using open source dependencies. It's not just your code. It's other people's codes, right? That's where things go a bit like turtles all the way down. And so let me show you. I think I have it here. So this is, let me take you to Dust helpers. So that condition that you saw there, if function, it gets, so this is the helper for Dust. So now we're like actually drilling, as you can see, to like my node modules, Dust helpers, and all the code that actually allows me to do this if condition, which makes sense. Like I have it as part of the app. Now, what happens if I scroll down a little bit, you'll see that I'm actually using the condition value in eval, okay? Probably a lot of people will know, hey, why are you doing this? Eval is eval, blah, blah, blah. Okay, so there are certain use cases, like, 99.9% you don't need eval. You probably shouldn't use it. But two things. First of all, sometimes you have to, for, whatever some reason, maybe like template engines like this will have to like render code at runtime and not by pre-compiling it first. One reason. The other reason is, you may not be aware, but other dependencies are using it. So like it doesn't help that you are avoiding it. Maybe others are using it. So we have eval here. By the way, that is not exactly where the vulnerability here comes from that we talked about before, code injection. But we still have eval. Now let's go into Dust, and I'll show you the Dust. By the way, it's pretty kind of like an oldie library, but it was known, if you like look it up, it's known for like being a very secure template engine. So they have enabled this escape HTML. So if I try to like pass any strings that it tests them, and they need to be like sanitized, or in this language actually output encoded correctly. Like I can't add a ampersand, I can't add a less than sign like this, right? If I add something like that, or just like try to add like single quotes, all of these characters essentially, it goes and output encodes them correctly, not sanitizes them, not removes them, but actually encodes them in a proper way. What it means is if I try to do mobile and you say I had like a single quote, like this is some debug here, you see it does the single quote, but it encodes it very correctly. If I try to do something like this, that's fine, nothing bad happens. So far so good. Agree?
Mm-hmm.
We're good with this. Okay.
Yep.
All right. So what I really want to do next is think of, well, let's take this to the CLI and try some different things. Okay, so let me see if I can actually make some which we copy this. Yeah, localhost. Let's say that I actually want to request one of these. Why is it doing it like that? Device equals mobile. Yeah. It'll be a lot easier to figure out what's going on. There you go. No shell escaping, so it's going to be easier to like also see what is the value there. So far, everything works okay. Let's go back to opening here. Okay, I'll open this is the terminal that does in VS Code the npm run start. You can see all this debug information. This is the server side answering, so it looks good. Now, if I try to add like a single quote again from the terminal, you see single quote device looks okay. Make it a bit bigger. It's clear. Start again. But here's the thing. This vulnerability happens because there's an issue of HTTP parameter pollution that leads to code injection. HTTP parameter pollution is essentially allowing me to kind of like fuzz the application. Like, this says device equals mobile, but it is a query parameter, and I can represent several of them, like a list, an array. So I can go ahead and say, hey, what happens if I add another device and call it desktop? I have no idea what the server does. Maybe the developer who built this didn't like put a specific, kind of like workarounds to handle this. Apparently, it looks like the app works just fine. You can see that now the actual value is not a string anymore. It actually became an array. Okay, so something is happening here. Now I'll go ahead and say, hey, we can represent an array also like this. So if I do it, I get the exact same thing. But remember when I tried just a single quote before and it didn't work? So now if I add a single quote, look at that. Like server error, unexpected string, things blow up, right? Like what's going on here?
Mm-hmm.
Now you can see the server erroring here. Now, if you look at this, tell me, talking about secure coding conventions, this is where the vulnerability actually lies in this open source dependency. Let's see if someone on the chat, while I'm kind of like, rambling here, is able to figure out like what is the vulnerability here and what we should have done different to basically be able to mitigate this issue. Let me know if anything comes up. Like a few seconds. Do some Twilight Zone music.
Sure. Yeah,
Okay.
I don't know why throwing that one single quote in there blows it up.
Okay, so here's the thing. The function does type of S is a string, right? And then it does all of this cleanup. But the moment that we've essentially went through and did this request, now device is not a string anymore, it's an array. So all of this logic that cleans everything up, I'll just kind of fold it, does nothing. It gets ignored, and we are just returning the string as is. So when that string is getting returned as is, it goes exactly into my template. And right, imagine that now the user input version of this logic is essentially, right, like mobile and then like a single quote. Yeah. So it messes the whole thing up. And because all of that value gets passed into eval, you see why this is a syntax error. Now, we can take it further and say, hey, you know what? Now that I know that I can actually execute code, I can try to do something like console log on the server side. So if you look at kind of like what I'm trying to do there, I don't have a typo. There we go. No, wait, there we go. So now I actually am going to run this. This statement will be correct in terms of like the JavaScript, the whole statement here that eval is doing is like a valid JavaScript statement. So the app looks like it's working just fine, but I've essentially ran console log 1 on the server side. Of course, I won't see it here because this is the HTML response. If I bring back my terminal here, you can see that this was the debug line from the app, and this was our code injection that did a console log 1 into the app. So this is server-side code injection that happens on a view that everyone can access, anonymous. I've basically not done anything wrong myself. This is simply, code injection in a dependency that I'm always using. And even though it wasn't very obvious at first, like even why and where things could like go bad, they did go bad. And I will tell you the thing that kind of explodes my mind about this vulnerability. So I don't know if you're ready for it, but here's the thing. This vulnerability wasn't discovered by someone looking at the code, by the maintainer, by a researcher, nothing. This was discovered by a person who does security bug bounties. So like essentially there's a company that puts their web app or whatever, says, hey, you can hack us, and if you find issues, let us know and we'll give you $1,000 or whatever. And so through that kind of program of like ethical hacking, they fuzzed it. Of course, they have like no access, like internal IP, like the code base, nothing. They just like a website. Basically, they interact with this. That's it. They fuzzy tested it and like ran some automation and everything around this, and they found the issue and they reported that to the company. That company went in, of course, confirmed the issue. And as they dug deeper to see like, why is this like a vulnerability that's happening to them, they realized that it happens because of a dependency that they were using that's called Dust.js. Then they reported it to the Dust.js library maintainers, via open source. That's how it got discovered. So while we think, hey, Liran is showing me this because he already looked at the source code and he knows this. Hey, you know what? Like people are using, their security or hacking kind of like skills to actually do this, without looking at anyone's code. There are enough tooling that allows this to happen, and this is how we find out about those kind of things. So yeah.
Wow, that is absolutely crazy.
It is
cool.
That vulnerability, by the way, he got for it $10,000, I think, and that's kind of like he wrote a blog and called it the line of string that gave me $10,000 or something like that.
Nice.
It was fun.
That's cool. Okay, we're a little over time now, but I think it was probably worth it. That was really interesting to learn about. Cool. Is there anything that you want to shout out or tell everybody or direct people towards, so all our listeners can go learn something new?
I'll definitely do that. So there's like a ton of, so I'm tweeting a lot about a lot of stuff, but on the Snyk website, there's just like a ton of learning resources, free, easy. You don't have to like sign up to whatever you want, even though like Snyk is free. There's like the blog, security. If you just want to learn about like all of this stuff that we talked about, this is like a new product that's pretty cool. And you can filter for whatever you want to learn and just start the lessons. So like really bite-sized lessons of like going through interactively. You see like this. And just like learning about security. So it's free, very easy to do. But what I really want to call out and shout out is we've running a campaign. I'm running this, and like I'd be happy if like people just like kind of participate. It's called The Big Fix. The idea is we really want to like recognize developers for fixing security issues in their projects or in open source projects that they collaborate with or whatever. It's a month-long event. On the 25th, it kind of like there's like a 24-hour live event, like a live stream with a lot of like sessions about security, about skilling in different sizes. It's 24 hours, so across the board, worldwide. But essentially, we want to hit the goal of like fixing about a little bit more than 200,000 vulnerabilities. You get participated simply by registering like to this simple small form, just your name and the email address that is used for like your Snyk account. And that's it. Like the moment that you fix a vulnerability in your app with Snyk, we'll send you a free Snyk t-shirt. So like that's the only thing you have to do. So we kind of like want to recognize, reward you for your efforts in helping them making the ecosystem and everything else more secure.
Nice. That's awesome. Okay. Yeah, no problem. Thanks for all the information. That was incredibly informative. Awesome. Yeah, I learned a lot about security. I hope everybody else did too. Remember everybody to go check out our Twitter to join some of the communities, and you can find Liran at Liran_Tal on Twitter, and I'm sure he tweets about all kinds of interesting security stuff all the time.
Yep. Thank you, everyone. Thank you, Jay, for hosting us.
No worries. Awesome. Talk to you later. See you everybody next week.
Bye-bye.